Martin and I are here to do Module 9 practice problems, and we are beginning this video with number 4. Martin, will you read number 4 to us?
Determine the shape of a PCl3 molecule.
PCl3.
Give its bond angle and draw a picture of it.
Ooh, how exciting. Okay. So, this is phosphorus chloride, right?
5A and 7A, respectively. 5A. 7A, yeah.
Okay, so we should call it phosphorus trichloride,
Yeah,
right?
Okay.
Okay. So,
there's 4 of them.
P was what, Colin? Say again, sorry.
Oh, this means it's trigonal.
Well, let's draw it out first. P is in 5, right?
Uh-huh.
So what does that tell us about its valence?
It's got 5 of them.
How about Cl?
3, 4, 5, 6, 7.
Cl is where? In 7, so it has 7. So what's it going to look like?
Well,
You
P
can
is gonna be at
see
the
that
center,
these
of course.
Cl's are all going to hang on to the P here, and it's going to have one pair of unbonded electrons, right?
Mm-hmm. So that's trigonal, which means that the
right. So it's a wait. Let's just work slowly through this. So this is a tetrahedron, right? This is one of the tetrahedrons.
No, this is a trigonal.
Excuse me. I understand that, but the trigonal. No, it's not 3 groups of electrons around a central atom. So this is look at this phosphorus. Okay. 1, 2, 3, 4 around it. That makes it a tetrahedron. How many of the legs are missing?
1.
Yes.
2.
One leg is, look, let's imagine that it had a different chemistry, and so there was another Cl over here. It doesn't. It can't. Okay? I'm just saying then it would be a complete tetrahedron. It would be a tetrahedral tetrahedron. If you guys remember the chart I made you draw, the tetrahedral, the pyramidal, and the bent are all types of the tetrahedron. Okay? Does that make sense to you?
Yeah.
Okay. So this is a tetrahedron, which is a pyramidal shape. So what is the pyramidal bond angle?
107.
It's 107 degrees. Okay? So now we're going to need to draw a picture of it. Okay? So, if you know, think of the thing that it looks like. It's okay. We want to have like 107 degrees. So imagine that's 90. Somewhere around like that, right? So it's something like that. It's not really a very good image, but these are this one, I guess, could be more dotted because it's sort of going behind it. Okay?
Yeah.
And these are on top. If you look online, I realize that the textbook does not have the best images of the Lewis structures. If you look online, there are a lot of great images of Lewis structures that you can see. You know, Google tetrahedral. Maybe I'll send you guys some links so you can see them. Now we're going to do number 5. Okay, it's the same type of thing. Read it out loud, please.
Determine the shape of a H2 molecule. Give its bond angle and draw a picture of it.
Okay, so hydrogen is, how many valence electrons does hydrogen have?
1.
Yeah, it just has 1.
It's a very simple.
So it's just going to look like H.
Yeah.
Right?
Yes.
What kind of bond is this?
A linear bond.
It's a linear bond.
180 degrees.
It is, like a line, 180 degrees. Okay, and the picture looks just like the Lewis structure. Hey, how helpful. Okay? That's it for number 5. Is there anything else?
No.
No, good. Okay, number 6.
Determine the shape of an SiCl4 molecule. Give its bond angle and draw a picture of it.
SiCl4. So where is Si?
It's 1A.
So it has 1.
Actually, no, it's a 4A.
It has 4 valence electrons. How about Cl?
It's got 7.
It's over in 7A. Are you writing this down?
Of course.
Okay, so all these Cl's, the 4 of them, with their 1 unbonded electron, are going to bond onto the valence electrons here on the Si molecule. So it'll look like, drawn slightly lower. Okay. Okay, so it's going to be pretty obviously what kind of shape?
A tetrahedron.
Yeah, it's one of the tetrahedrons. Which of them is it? The tetrahedral, the pyramidal, or the bent?
It's the tetrahedral.
It is. It's the one that has all 4 legs in place, right? So it's going to, one is going to kind of stick out the top. Whoops, right there. Si. Hello. One is, and oh, what's the bond angle of a tetrahedral?
90 degrees.
This is another thing you definitely have to memorize, okay?
Or just use the handy dandy thing we wrote down. Hold on a second. It's 109.
Yeah, that's where you have to memorize that, okay?
I already wrote it down.
Number 7?
Yeah.
Or number 6? Good, you're done with number 6. Yeah, so the picture will look like this. It won't look exactly like the Lewis structure. And it has a 109-degree bond. Okay. Number 7.
Determine the shape of an H2S molecule.
Okay, where is sulfur?
It's in 6A.
Okay, so sulfur has 2 open spots, and that's where the hydrogen is going to bond, right?
Yeah.
Okay, so you can see that sulfur has how many around it? 1, 2, 3, 4.
Yeah.
Right? So that makes it a tetrahedron.
Yes.
Okay? Which of the tetrahedrons is it? How many legs is it missing?
2. It's
Missing 2 legs. That makes it not the tetrahedral, not the pyramidal, but the
emacial.
bent.
I mean emacial.
Not emaciated. That would be. Where's your chart? There's your charty, Marty. Bent. Okay, so 2 of the legs are missing. You see that? Here's a leg and here's a leg. They're missing. So this is a bent tetrahedral. What makes that the bond angle, my son?
105 degrees.
Approximately 105 degrees. Okay, so how is our picture going to look of it? With it trying to indicate the bond angle. Okay? That's what our VSEPR image can look like. This is the last one we're going to do in this video is number 8. Are you going to read it or should I?
You do it.
Determine the shape of a CS2 molecule. Give its bond angle and draw a picture of it. Okay. So here we have carbon and sulfur, right?
Mm-hmm.
Carbon disulfide.
Mm-hmm.
Can you look at the, come on, we have to, the 4th one we've done.
Carbon is 4.
Okay. Sulfur?
Sulfur is 6.
Oh. Okay, so sulfur has 2 open spots, right?
Mm-hmm.
So it's actually going to form a double bond, right? We're going to have a double bond here. And a double bond here. Can you see why I knew that?
Yeah.
Good. And how would you describe the shape of this?
Linear.
It is. It's going to be linear, right? Because they're the same. If they were not the same, we would have to look at electronegativity and things like that. So it's going to be linear. That means the bond angle will be 180 degrees, and the picture will look like the Lewis structure. So we don't need to draw anything else. Okay, so that's it for this video, and we'll come back in a final video.